Going to see some more complicated examples now. Let me just say that a sort of general principle is that every system of linear equations or SLE for short, so often we'll just say SLE. So we kind of talked about this a little bit last time, but I just wanted to remind you. So every system of linear equations either has a unique solution okay. So by unique, I mean it has exactly one solution. Or it could have an infinite number of solutions, so infinitely many solutions. Okay. And the third possibility is that it could have no solutions. Okay. When it has no solutions, there's a name for this. So a system with no solutions is said to be inconsistent. So if you ever see the word inconsistent, or if you're asked, like, is this system consistent or inconsistent, it's asking, is it the case that there's no solutions? Okay. So we kind of started doing this a little bit last time, but now we're going to kind of have a more, we're going to keep on looking at kind of a systematic way of, so when you're given a system of linear equations, you need to classify which of these three things happens. Like, does it have a unique solution, no solution, or infinitely many? And if it has solutions, you need to be able to classify them. Okay. And so we started talking about something called the Gauss-Jordan method. So I'll just remind you of these elementary row operations. So first of all, you can swap two rows. Okay, and here we're thinking of, we've got some kind of, so we always want to transfer everything into matrix form, and then we have these row operations. So the matrix, remember, it's something that looks like a box with numbers in it. What you're allowed to do is you can swap two rows, you can multiply a row by a non-zero number. And the third thing you're allowed to do is add a multiple of one row to another. Okay. Okay, and generally speaking, so you'll be given a system of linear equations or given a matrix, and you want to apply these rules in some order, like, you know, to sort of simplify your matrix to get it in a specific form. So let me tell you that something about reduced row echelon form. So we want to get the matrix in reduced row echelon form. So that's too long to write every time, so usually I'll just write RREF. I have no idea what echelon means, so I don't really know why it's called reduced row echelon form, but that's what it's called. Basically, if you get a matrix in reduced row echelon form, it's kind of the simplest form that it could be in. And basically, so you're going to start with some kind of ugly matrix that's got various numbers in it. And you want to get it to the simplest possible form so that you can just read off the solution really, really easily. Okay, so let me explain the properties of reduced row echelon form. They're going to seem a little bit abstract and not really intuitive. But the hope is if we go through a few examples, you'll get an intuition of like, what is this? What is reduced row echelon form? So here are the rules for reduced row echelon form. So there's 4 properties of this. So the first property is that every row of zeros is at the bottom of the matrix. So when I say a row of zeros, I mean like a row which is literally 100% zeros, right? Which at this point you might think, I don't even know why there would be a row of zeros, but all we're saying is that they have to be at the bottom. Yeah? You're trying to get it to like this. So you're going to be given like some ugly matrix with a bunch of weird numbers in it, and then you want to like apply these rules in some order, and to get it like this. Yeah. Oh, this is going to be basically explaining that again. Like this is going to be like you're going to have ones and zeros. However, so last time we just focused on trying to get it like this, and then some stuff here, right? Here's the thing. Not all systems can be turned into this. So actually, this is just going to be a little bit broader of a criteria. Because sometimes you can't get it like this. You might have, for example, a row of all zeros. And so this is just going to be a little bit of a more general format that you could get it into, where you can still get the answer, basically. But yeah, that's a good question. This would be reduced row echelon form, but it's a bit more general than that. So we'll see some examples, but yeah, so there's 4 properties. The zeros have to be at the bottom, the rows of zeros. Secondly, another thing, you're going to have to be able to recognize if a matrix is in this form or not. So this isn't just about solving them, but you need to know what these 4 rules are for reduced row echelon form. So the first non-zero entry in any row is a 1. Unless it's a 0 row, but then there is no first non-zero entry. So basically, you put the zeros at the bottom. If you look at a non-zero row, if I go from the left and look at, it's 0, 0, 0, 0, 0, and then you see a 1, then that's good, right? So the first non-zero entry in each row is a 1. Third thing is, in any two consecutive, so when I say the first non-zero entry is a 1, we call this like, it's got, every row has a leading 1, so it just means the first thing is a 1. So in any two consecutive non-zero rows, the leading 1 in the lower row is further to the right. Okay. Okay, so these are 3 properties. I need one more property. Sorry, but I'm going to write this here because more room on that board. This is property D, so this is continuing this list here. So if a column contains a 1, then all the other entries are 0. In that column. So all other entries in the column are 0. So this is the fourth property of reduced row echelon form. Okay, so this is all really like super kind of dry and boring kind of rules. It might seem a little bit confusing, but like if you do a few examples, you'll get some feeling for what this is. So let's do an example. Okay, so what I want to do, I want to apply these 3 rules kind of over and over and over to turn that matrix into one that's in reduced row echelon form. Okay, so here's the kind of process. What I would generally do with these types of things is I would start with the first column, right? What we're going to try to do is get a 1 in that first column. Sometimes they call this, you'll probably see this in the textbook, like pivoting a column. So to pivot a column means to get a 1 somewhere in that column, and then to get everything else to be 0 in that column. And specifically, it might be nice, like we kind of want to get in some sense, we want to get a 1 in the top left corner. So right now we've got a 3, which is obviously not a 1. So what I'm going to do is I'm going to divide that whole row by 3, right? So if I divide row 1 by 3, so my first step, I take 1/3 times row 1. That's one of my allowed operations. That's the second operation in this elementary row operations. So I get 1, -2, and 3, and then 0 on the other side of the vertical line, right? Okay. So that's like half of what you have to do. So I'm sort of pivoting the first column which means I'm trying to get, in the first column, 1, and then 0, 0, 0, 0, 0. So I've got my 1. Now what I want to do is get zeros everywhere else, right? So how could I get a 0 in this position? So what I can do is I can just, if I subtract 4 times the first row, I'm going to get a 0 there, right? So I'm trying to shoot for 1, 0, 0. And yeah, if I want to wipe out this 4, the best thing to do, if I take my first row, I subtract 4 of them. So what I'm doing is row 2 minus 4 row 1. Then I am going to get my 0, right? And you have to, when you do the subtraction, you have to do it everywhere, right? So this position is 4 minus 4 ones. This one was negative 6. So this 2, for example, comes from negative 6 minus 4 times negative 2, which is 2, right? Is everybody with me on this? Yeah. Yeah, so I'm taking my second row, which was 4, negative 6, 8, and negative 4. I subtract 4 times the first row. The first row has a 1 here, so I take 4 minus 4 times 1. Here I have negative 6 minus 4 times the thing above it. Right, that's where the negative 2 is, it's right here. So row 2 minus 4 times row 1. I just kind of look in each column and I take the number I have in row 2, subtract 4 times the number in row 1 that's above it. Yeah? So this negative 4 then is just this 8 minus 4 3s. If I take 8, so what does it mean to subtract 3 4 times? It's subtracting 12. Right? Yeah? So it was originally negative 4, right? And then I subtract 4 zeros. It's still negative 4. Yeah. So this 0 is kind of helpful, right? It makes your life a little bit easier here, that you don't have to do anything. Any other questions? Yeah. Yeah, we're going to go through all the steps. Yeah. Oh, sorry. You mean all the steps of just this step? So. Yeah. But, well, I mean, the only thing to really understand is I'm taking my second row, and I'm subtracting 4 times the first row from the second row. So there's really not anything. After that, it's all just how do you subtract numbers, basically, at that point. Like, so I'm taking, so my second row is 4, negative 6, 8, negative 4, right? My first row is 1, negative 2, 3, 0. So here I just take the number I have, which is 4, subtract 4 of those to get 0. Okay. My whole goal in life at this point is to get a 1 in this first column, which I already have, and get everything else to be 0. How do I make this a 0? Using that 1. If I subtract this 1 4 times, I'll get a 0 here, right? But what you do in one column, you have to do in every column. So here what I'm going to get, instead of having a 4, I've got 4 minus 4 times 1, because I'm taking row 2 minus 4 row 1. But that's 0. Here, I'm getting negative 6 minus 4 times negative 2. Here, I'm getting 8 minus 4 times 3. And there I'm getting negative 4 minus 4 times 0. Right, and these are the numbers I've got here, 0, 2, negative 4, negative 4. Is that becoming a little bit clearer? So this is just saying, how do I do these row operations? So all I'm doing is I'm adding a multiple of one row to another row, right? Yeah. So I guess this all just boils down to, what does it mean to take row 2 minus 4 row 1, right? And then after that, it's just how do you add up and multiply numbers. It's not anything more complicated after that. Okay, so I haven't really succeeded in my first column here yet. I want 1, 0, 0 in the first column, but I've still got a negative 2 sitting here. So what should my next row operation be? Yeah. Yeah. Exactly. So, right, because you can kind of see, what do I need to do to get rid of that 2? Well, what I could do is take this 1 and add it to this thing twice, and the negative 2 is going to be gone, right? So yeah, so I take row 3, I add 2 times row 1. Okay. And now I'm really happy about my first column. It looks exactly how I want it to look, right? So this process that I've done here is called, what we've done here is we've pivoted the first column. I don't really know why it's called pivoting. But basically getting your first column to look like a 1 with a bunch of zeros is called pivoting the first column. Okay. So yeah, again, this is just kind of arithmetic here to figure out why this is 0, negative 5, 5, 7. You just do the operation. So you take negative 2 plus 2 times this, negative 1 plus 2 times negative 2, and so on. Okay? Okay. So what I want to do next, so I've got my 1 in the first column. I want to get a 1 in the second column, but I want that 1 to be on a different row. Right? So I've got a 1 in the first column, first row. I want to get a 1 in this column, but I don't want to do it on the first row. I want to do it on the second row or the third row. It doesn't really matter which one I pick. So maybe let's pick, well, which one did I do here? Okay, probably a natural choice is to pick the second row. Okay, so what I'm trying to do now is pivot my second column. So what I can do is get a 1 here. The best way to get a 1 there is to just divide that whole row by 1, or sorry, by 2. Okay, so is it clear how I went from this matrix to this one? Just divide the second row by 2, right? And now, like this, hopefully you can see why it's useful to have 1s, right? I don't know. Like when I've got a 1 here, it kind of makes the arithmetic a little bit easier to realize, how do I annihilate that negative 2? If I take this row twice and add it to that one, that's going to kill that negative 2. If I take this row, I add it to this one 5 times, that's going to kill this negative 5. So I think maybe next I've done those 2 steps in one step. So this will save you a lot of writing if you can occasionally do 2 steps at once. Otherwise, you're going to have to do a lot of writing. But yeah, here I'm just doing exactly what I wanted to do. So I'm saying I take my first row, I add 2 times the second one to get rid of that 2, that negative 2. And simultaneously, I'm taking row 3 and adding 5 row 2s to it. Okay. And now I've pivoted my second column. It now looks really nice, just 1, 1, and the rest are zeros, right? Any suggestions what I should do for the next step? So I want to make so I've done my first 2 columns. They look nice. I want to make my third column look nice, like just 1s and zeros. Any thought what I might want to do next? Yeah? Oh, sorry, yeah. Yeah, that's what I like. So yeah, take this whole row here, multiply it by negative 1 over 5. That'll give me my 1. And then once I've got that 1, I can just annihilate everything in that column, right? So yeah, I like that suggestion. I'll do exactly what was mentioned here. Take my row 3 times negative 1 over 5. That gives me my 1. My negative 3 becomes positive 3 over 5, right? And then we're almost done, because all I have to do is get rid of that negative 2 and that negative 1. I just add the third row to do that. So row 1 plus row 3, row 2 plus 2 row 3s. Okay. And okay, these numbers are kind of ugly, but this is basically showing you, this is actually going to happen quite a lot probably, that you're going to get fractions. Don't be afraid of fractions. It's just something that can happen. So the negative 17 over 5 comes from negative 4 plus 3 over 5, right? This negative 4 over 5 comes from negative 2 plus 2 times 3 over 5, right? Is it unclear where any of these numbers come from? Okay. So I probably should have kind of said this more at the start, but this original, let me go back to the beginning here and look at our original matrix. We'll go back and look at the answer again, but this original matrix so what that matrix really represents, so I mean, those are just numbers in a box, but what they represent is the equation, the linear equations 3 times x minus 6y plus 9z equals 0 for the first row. So this matrix represents this equation, this equation, Okay. And what we've done by doing these row operations and getting it into reduced row echelon form, so by the way, the final thing we got, so this is our final kind of answer here. So this is in reduced row echelon form. What this is saying is that these equations are equivalent to so they have the same solutions as the equations represented here. But these equations are super, super simple. So what does this equation say? It says x equals negative 17 over 5. The second one says y equals negative 4 over 5. And the third one says z equals 3 over 5. Okay. Yeah. Yeah. So basically, yeah, so this is the unique solution to these three equations. Okay. Yeah. So basically the idea is you start with these ugly expressions that you can't really see what x, y, and z are. And you, by doing this process, you sort of manipulate it to get a final three equations where you can just read the numbers off of them, right? Because this equation is just saying 1 times x equals negative 17 over 5, right? So when you get a situation like this is a case where you have a unique solution, right? Okay. Any questions about this example? Okay. Well, let's do another one. So this time, instead of starting with a matrix, I'll start with some equations. Okay. So basically the question would say, here are 3 linear equations. Please find the solution if it exists, right? Or if it has infinitely many solutions, then you need to say what they are. But basically, the question is solve these 3 equations. Sorry. I'm not really used to this thing. This thing is not very responsive. Right. Okay, so these are our 3 equations. So the first step is to turn this into a matrix. However, you need to be careful. Like, okay, so this is going to be a matrix. Definitely, it's going to have 3 rows. So my first row is kind of simple. I just read off the coefficients. So my first column is going to correspond to the x coefficients. This one's going to be the, then you're going to have the y and then the z. So, okay, so this should be 2, 2, 4. And then this line represents equals. So we have 8. Right? Does anyone recognize something strange about my second equation, though? Like, yeah. Yeah. Actually, I'll keep the 2 on this side, but the, or sorry, yeah, you could do it that way. You could put the 2 on, it doesn't really matter which way you go, but what I'll do is I'll take the variables, I'll put them over there with the x, and I'll leave the 2 on this side. But it's the same as what you said. It turns out to be the same. Right, because my equal sign is kind of in a weird spot. You always want to turn it into having all the variables on one side, all the numbers on the other side. So in other words, my second equation is the same as x minus y plus 2z equals 2. Right? And then I can put my coefficients in the matrix. Okay. So this is one thing not to get scrambled on. Like if these are all kind of mixed around, you want to get x, y, and then z. Yeah. So I'm just taking this equation that says x equals that stuff. The 2 is right there. It just stays where it is. I'm just moving the variables to the other side. Yeah. So yeah, this equation here is the same as the one that's up there. It's just rearranged. And you want to have your variables in the correct order, x and then y and then z. So, and then you put them in your matrix with the x, the y, and the z. And then on this side, you put the number that it equals. The third one, okay, that's straightforward. It's just -1, 5, -2 equals 2. Right? So this is a step you need to be able to do even before you start solving your system. You need to write down the matrix correctly, right? Okay. Okay. So yeah. Okay, so I've got my matrix now. I want to pivot my first column. Lots of things you could do. You could just take the first row, divide it by 2 to get a 1 there. That would be fine. You have lots of options, right? I could just take my second row and then switch it with the first. So that's what I'm going to do. So to get a 1 in the top left corner, all I'm going to do is switch row 1 and row 2. Okay? So remember, that's one of your allowed operations. You can just switch 2 rows. Okay, and now I've got my 1 in the top left corner. Okay. Anyone see what would be a useful thing to do next for the Gauss-Jordan elimination? Yeah. That'll work. I think that's probably not the one that I've got written on here, so, but that'll totally work. If you want to get rid of that 2 in the middle, you could, as you said, you could take the third row and add it twice, right? And then it'll be gone. I think probably what I did in the notes, so, is just take maybe the second row and subtract the first one twice. But at the end of the day, it does the same thing. But yeah, I guess that's the danger of asking for suggestions, because there is honestly, there's multiple ways to do every question. So there's nothing wrong with what you said. So I'm also going to, at the same time, I'm going to take the third row and also add the first row. So I'm just going to do 2 steps in one. Row 2 minus 2 times the first row, and row 3 plus the first row, right? And again, the reason for that is I try to get a 0 here and there, right? And if you do the arithmetic, you'll see that these are the values you end up with. Okay. Which looks a bit weird now. I've got 2 rows that are the same, but there's nothing, wrong with that. Is it unclear how I got any of these values? It's okay. Okay, so my first row is my first column is good. I move on to my second column. I'll just take this number here, right? I'll just take my second row and divide it by 4, right? Then that'll be good. So I end up with this. So both of those 4s become 1s. Okay. And then I do, so at this point, maybe it's kind of clear what I do, right? I take row 1 and I add row 2 to it to kill the -1. I take row 3 and I subtract 4 times row 2. But then I notice this hasn't really ended up the same way as the last one did. Right? This has ended up as something a bit different. When I